Okay. Started here in a second. Get this all set up. Okay. Before we get started, anybody wants note paper? Note paper. So we are now on should be 5.5 or higher, wherever we are, we're in 5.5. I can't remember if I mentioned it last week, but guys definitely take more handwritten notes. Like I said, you're going to for a few results I feel like are a lot higher than the next hour, where they take more digital notes. So I thank you guys for taking your handwritten notes, and it's definitely paying it off. Did anybody I missed wanted paper notes? Okay. All right. So we got the Zoom recording for distance learners, but nobody's live watching. So let me. Okay. So last week we talked about the first and second agricultural revolutions, right? Yeah. And we ended talking about the second agricultural revolution, which is basically that humans started recognizing that, oh, we can actually do things to our crops. We can have different types of technology to make them more efficient. We can actually use less labor on the farm, and we can actually use more land and get more food, more products that we can now sell. We've gotten to the stage in humanity where we're now making more food, at least in developing countries, make more food than what is needed in the community, so we can export them and sell them. Now, is this happening in Africa yet? No. Or Southeast Asia? Yeah. No. So we're going to now talk about the Green Revolution, which is kind of the third part of this trilogy of where we're at kind of now. Some could argue that we're in a new revolution, the biotechnology revolution. But right now, at least for College Board and for the AP test, it's all still part of the Green Revolution. So got some cool, funny memes there to get us started thinking about what the Green Revolution entails. Okay, so just real quick, what do you think is the Green Revolution? See, I make these like collaboration boards, and then I realize, oh, I've already talked about this, so there's gonna be a lot of similar answers. I'll give you a minute here to start posting some answers. Another good thing to think about is like, why do you think they call it the Green Revolution? Okay, so increase in agriculture, increase of crops, okay. So whoever put where pesticides and fertilizers were used to increase production of crops, whoever, I'm not going to have you don't have to raise your hand, but you hit it right there, nail. nail on the head, right there. The green revolution is where we're now starting to use some more fine tuning of science, specifically developing pesticides, because one of the biggest inhibitors of having these massive, or the reason they needed such massive farms, because a certain percentage of your crop was going to go to waste, was going to get destroyed as a result of pests. You guys ever studied the Irish potato famine? Or anybody ever heard of the Irish potato famine? A couple of you guys. We'll talk about that and how genetically modified organisms play a role in preventing something like that. But essentially, in Ireland in the 1800s, Ireland was primarily, their main source of food and export was potatoes. And then they had a fungus that developed that pretty much devastated the entire potato crop. It's what caused a lot of Irish to immigrate to the United States during the first mass immigration wave. But anyways, so a lot of the crop was destroyed, and it took a long time for it to naturally recover. But then started developing herbicide, which is or fungicide, which was used to destroy the fungus. And now Ireland doesn't have as much issues with their potatoes. Okay. So with the third agricultural revolution, aka the Green Revolution, so you'll probably see it being referred to as the Green Revolution on the AP test, or the unit test as well. Invention of high yield grains, especially rice, with the goal of reducing hunger. So some more intelligent individuals around the 1950s and 60s were thinking, okay, the world has so much poverty. There's a lot of people malnourished who aren't doing well. And so how can we give them some practices to make them be able to grow more product, more crops a little bit more effectively? So increase the production of rice. Where does rice typically grow?
Asia.
Okay, yeah, Asia. Thinking about East Asia, Southeast Asia, warmer climate. It's going to be better, warmer, wetter climate. Rice counts for nearly at least 40% of the world's food supply in developing countries. Same goes for wheat and corn. Now we got to start thinking about how do we make it so that we can get the most bang for our buck, how we can prevent pests from destroying our crops, how we can better suit our crops to exist in harsh environments, prevent famine. So famine, term used to describe when there's a period of very little food production in a country. So the Irish potato famine, we have the Soviet food famine of the 1930s that was responsible for the deaths of millions in the Soviet Union and Ukraine. We have the Dust Bowl here in the United States in the 1930s, which resulted in a famine. A lot of different famines out there. Modern famines happen all throughout sub-Saharan Africa, parts of South Asia, and into parts of South America. So this is in 2016, malnourishment in the world. So the way we define malnourishment is basically, we have the average or the vitamins and nutrients needed to basically the bare minimum to survive. If you're not getting the right amount of vitamin A, vitamin D, vitamin C, then you're considered malnourished. And so as you can see on the map, where are most of the malnourished people in the world?
Africa.
Well, specifically, what part of Africa?
Middle. Central.
Well, what's the term we use?
Sub-Saharan.
Sub-Saharan. As you can see right here. Why do you think that is?
Good.
Well, hold on. Why do you think sub-Saharan Africa has the most malnourished the rest of the world? Think back, demographic transition model. Where are these guys? Are they in stage 4 and 5?
So,
Or are they probably more in stage 2, maybe early stage 3? Okay. What we notice is that the agricultural revolutions mimic the demographic transition model. Stage 1 is just like stage 1 of the demographic transition model, same as the first revolution. If your country has developed agriculture, then you're, stage 1. If you're at that second agriculture revolution, then you're in stage 2 and 3. Okay. If you got to the green revolution stage, then now you have the potential of getting into 4 and 5. So based off of that, does that tell us that Africa is still probably in the first or second agricultural revolution? That they have some basic tools, like they have a steel plow, but they still have to use like oxen to pour it through. Do you think that they have a lot of tractors, gas-powered machinery in sub-Saharan Africa? No. What we're going to start seeing, because sometimes it can be said, oh, the Green Revolution ended world hunger.
yes.
It did not. It improved things, because if we looked at the same map, I couldn't find one, but if we looked at one from 1940, we would probably see a lot more red, especially in Southeast Asia. Southeast Asia has benefited more from the Green Revolution than any other part of the world, especially in India. Okay, so this is just showing the average caloric intake or consumption per capita. We eat a lot here in the United States. They eat a lot in Europe. But are they getting a lot of calories in sub-Saharan Africa? No, it's not because they're not working. It's because lack of access to food. So there's been some opposition to the Green Revolution. Biggest thing is vulnerability to pests. Soil erosion, water shortages. Water shortages is a big one that we have to deal with out here in Utah. We benefited from the Green Revolution in Utah because we're able to grow crops that normally couldn't grow out here. But consequences of that is that agriculture takes up over 60% of our water supply. And this year is going to be a drought year. Our snowpack is already well below what it should be. And so we are going to have to conserve water this year, especially when we get around to late July, early August. But farmers don't have to conserve their water or their water consumption here. It's usually up to us, the average citizen, average resident to conserve water. Micronutrient efficiency. So one of the bad parts of the Green Revolution that some of our food got less nutrient rich. Basically, one of the bare minimum nutrients are coming out of some of this food. Dependency on chemicals for production, such as pesticides, herbicides, and fertilizers. So we know pesticides and herbicides. What's the difference? What does a pesticide do?
Pest.
Well, if I spray a pesticide on, say a bushel of corn,
Kills it.
well, it doesn't kill the corn, but what does it kill?
Pest.
The pest. Usually for corn, that's mealworms. But what does herbicide do instead? If I have an herbicide, Roundup Ready, or Roundup, what does Roundup do? That's used to kill weeds, things that are interfering with the crop. So it's important to know the distinction between herbicide, which is killing weeds and other plants around it, or problem plants, versus a pesticide, which is going to be killing, as it says, pests, other living organisms that are trying to interfere with the crop. Now, with this, so like say you can now use this pesticide or the herbicide, so Roundup, which is created by Monsanto. If I am a farmer in sub-Saharan Africa or Southeast Asia, and I need to buy Roundup, is it gonna be easily affordable for me versus Farmer Joe in Iowa? If I can't afford to pay cash for my item, what am I gonna have to do? What usually happens if you can't pay cash for something?
Trade to pay it off.
Yeah, you have to pay on credit. So one of the problems with the Green Revolution is that you get farmers, especially in developing countries, who are like, yeah, let's use these seeds, let's use these pesticides, herbicides, but they can't afford it. So either their government will purchase the products from like a company like Monsanto, but now they're in debt to a company like Monsanto. Monsanto can come around and say, oh, we're actually going to take some of your land and use it for our agricultural use. No longer your individual farmers. Or now that farmer in sub-Saharan Africa is now indebted to the government. So a lot of the technology that resulted in the Green Revolution was developed by private companies. Like Monsanto, like John Deere. These companies, are they doing this all for free? Exactly. They're trying to make literal bread out of the wheat. No, obviously they're going to, make these products so that they can make money. Monsanto is almost a $1 trillion company, like Amazon. And they all make it off of this technology they developed. They have patents on it. That means that you can't buy an off-brand Roundup. That specific formula that works well, you can't. Now, when we get into GMOs, we're going to talk about what we call Roundup Ready seeds. You guys ever heard of those? Monsanto has developed seeds like, for corn, for wheat, for soybeans, that they're genetically modified so that way when you plant them, they're resistant to Roundup, because Roundup kills pretty much everything. But they've developed these seeds that will grow, and when you spray Roundup on it, the plant will survive, but everything around it will die. That's another problem, because now you have to buy the seeds and the Roundup from Monsanto. Not even talking about the cancer-causing chemicals found in Roundup. There's a guy, father in California, who won a $2 billion settlement against Monsanto because he contracted lung cancer and died from Roundup. Plant breeders' rights and patents generally not relevant, meaning that individuals who come up with formulas usually get overshadowed by larger companies like Monsanto. Increased monoculture and use of farm chemicals lead to marginalization of small farmer, ecological degradation. So this idea that we're now limited to 5 different crops in the world that are primarily the foundations of our food, versus 100 years ago when we had hundreds of different crops. Now used to be that you drive down a farm field or down farm fields in Iowa. 100 years ago, you'd see hundreds of different types of crops being grown. But now it's either corn, soybean, or wheat. So, real quick, do you support or reject the Green Revolution?
I support it.
We'll kind of get a little more clarification on the green revolution when we talk about GMOs. And you'll find out that this is a very heated debate. There's going to be some of you who are very much like right now. Some of you might be like, yeah, I support it, or I don't think it's right. But after we see a lot more evidence and the science behind, what went into the revolution eventually, GMOs, then I think we'll get a lot more division in class. Yeah, division. No, there's like natural opinions. Okay, just wait for a couple more responses here. So I think like a lot of you guys will kind of be, more in the middle ground, like saying, yeah, there's pros to it, there's some cons. I'm just not fully aware yet. Some of you, still like, I don't want to make a decision yet. Some of you like talk about like the potential after effects. So like, using Roundup, does that cause cancer? Does it really benefit developing countries? Because the whole purpose of the Green Revolution was to better our food supply, so that way developing countries or countries in poverty could reduce their hunger, malnutrition. But as we saw in that map, 5 years ago, still a big chunk of the world's malnourished. The thing that kind of disgusts me, and this is where my own personal opinion comes into this, is I used to work at a grocery store back in Iowa, and you'd have all the different products out there, fruits and vegetables, and we had in the back of the back of the store, we had compost bins, as big as like half of this classroom, full of to my mind, perfectly good fruits and vegetables. I asked the manager one time, like, well, why do we throw all this stuff? It's like, oh, well, because it has this little blemish here, or there's a dent in this fruit. Nobody's going to buy it, so we just throw it out, even though it's still safe to eat, and perfectly fine to eat. We developed a culture here in the United States and in developed countries of our produce has to be pristine, uh, in order for us to buy or use it. Think about if you ever go to a Walmart on a Sunday evening after everybody's done their weekend shopping, you'll see all of these like onions and bananas that visually look, not the best in our opinion, but they're still plenty of good to eat and utilize. And so the problem is that why aren't we sharing more food with developing countries? Another thing is you guys heard of farm subsidies here in the United States. Farmers in Iowa, if they don't sell enough of their product, the government will buy it and store it in silos, and a lot of time it gets thrown out. We don't export it anywhere. It just sits there and rots, because we want to keep the farmers happy, but we don't have sometimes enough buyers, because developing countries can't afford our prices. But that's why a country like Brazil is making a lot of money, because they sell a lot cheaper prices, grains and stuff, to developing countries. Okay. So this is where the Green Revolution, this is for AP, we'll consider it still part of the Green Revolution, but some geographers have classified it as the bio revolution. Now we're really getting into the science. We're actually taking the genetic components of our food, of our crops, and modifying them to be able to, make certain, improvements. Whether that is making it so that if we spray Roundup, the plant's not going to die. Or we make it so that it'll produce more ears of corn on a stalk. Or we can make it so that an enzyme within the piece of corn, and when it's digested by, say, a field mouse, that mouse will die. But it's perfectly safe for us to eat. This is kind of the next generation of agricultural development. Once again, all this technology is being held by private companies. Problem starts arising is that if you start modifying crops and you put out a field worth of these crops, they're going to spread to other fields just naturally. And then now we have a hodgepodge of different crops out there, some genetically modified, some natural. But because they're genetically modified, there's certain components you have to buy and use on those genetically modified. And so some farmers are forced to then buy genetically modified seeds. And a lot of these companies, like Monsanto, they have you buy new seeds every year. It used to be that a farmer could buy all the seeds they want and last for several years, but now they have to buy them every single year, brand new seeds, because genetics are constantly changing amongst crops. Any of you guys ever watch, maybe I asked this last week, the movie Interstellar with Matthew McConaughey? It's a really great film. I think you guys maybe, I don't know, this will be maybe one of the films we'll watch after the AP test. It really talks about how society got so much into genetically modified organisms that eventually crops started dying out. We lost our genetic biodiversity, which ultimately led to soybeans going extinct, corn going extinct, and so they had to find a new planet. So, opposition to the biorevolution. Genetically engineered crops are yielding ethical problems. Farmers typically keep seeds from crops so that they can plant the seeds next year, but some GMO crops don't produce seeds. So you have to buy the seeds from the producer. A lot of farmers, even just small town farmers in Iowa, can't afford this stuff. And so they end up going and working on a commercial farm because a big company that owns several hundred square miles of farmland can't afford these things versus, Farmer Jane or Farmer Joe. And depending on the farm size, because sometimes with these crops, you have to have a large farm. If you have a small farm in a country like Bangladesh, you're not going to be able to utilize this technology. See, like for me personally, I'm still very undecided on, my attitudes and general feelings towards the biorevolution and towards GMOs. Even though it sounds like I'm maybe attacking Monsanto, but I'm more upset at Monsanto as a corporation as opposed to the science that they're utilizing, because corporation is trying to take advantage of poor farmers versus the actual technology, which I think the technology of some of the GMOs would be perfect if everybody could benefit from it. But then on the other hand, it's like, a company like Monsanto's not going to develop if they can't make money off of it. So it's like a very stuck between a rock and a hard place. So typically with the bio-revolution, we're seeing less women being encouraged to work in farming, which in a developing country is very problematic. We spend a whole section, we'll talk about women and agriculture next week. Like for example, they've made some farms in Gambia year long for rice production, which has forced women who traditionally work on those farms or own those farms to not be able to work anymore. And men are forced, or men take over that position. So now we're getting lands that were once used as subsistence farming, subsistence agriculture, are now being used year round for commercial exportation. So if we look at Southeast Asia, where we have lands that are now being used for commercial farming, and those profits, that money is going towards the men of the family, and the women are becoming less and less active and involved. They have less of a say in how the land is used and utilized, which is obviously problematic for women's rights in some of these parts of the world. But we'll talk a lot more about this next week. Okay, so it brings us into the highlight, the focal point of today, GMO. What is a GMO? So we know it's a genetically modified organism, but maybe if you could provide an example or. Okay. Okay, material has been artificially manipulated in lab through genetic engineering. Yeah, so actually going in and looking down to the molecular level and modifying the genetics of animals and crops. Okay, so good responses so far. So what is the difference between genetically modified organisms and genetically engineered organisms? So, like I said, this can get very heated, and I think after we watch the videos and look at some debate, you guys will get different perspective. Yeah. To what? Yeah, real quick. Well, this is like kind of like, the formation of GMOs really kind of sparked this like debate and this movement of, should we resort back to organics, growing like we did even back in the first agricultural revolution. That's why you guys ever go to Walmart and see the organic section. Now, gotta say that organic section of Walmart, they're full of GMOs. Even if you're buying organic, it's still GMO. Unless the product specifically says it's GMO free or not GMO, it's going to be GMO. I can guarantee that. So this is an example right here. On the left is the organic original version of that crop versus the right, which is what we're used to seeing. What's the original form of a banana? Anybody know what it's called? Plantain. Plantain on the left versus regular banana on the right. How about carrots? How many of you guys would eat the one on the left? If I just handed it to you and said, oh, you should eat this. Versus the orange, nicely grown one on the right. How about corn? Maize. On the left, that's pretty much what corn used to look like. How it was naturally found in the Americas and Latin America. Versus on the right, what we're used to seeing today. What about eggplant? That's kind of a crazy one. On the left, it kind of looks like, from afar, it looks like a little pumpkin. But then we're used to the purple shape on the right. And then watermelons. The one on the left looks kind of odd, doesn't it? So everything on the left is, naturally produced and was pretty much found and grown, prior to the 1950s and 60s. Versus on the right is kind of what we've culturally, socially accepted as normal food. Like I said, if I gave you anything on the left column and I said, oh, here's a carrot, and I give you that carrot, you'd be like, no, that's not a carrot. It is, actually. Man has been manipulating DNA in plants and animals for millennia. This idea that GMO is purely something that's come out of the 1950s and 60s is false. Now, the idea that we've actually gone into a laboratory and gone down to the molecular level and changed organisms, yeah, that's something that's been done recently. But ever since the first revolution, we would, a farmer family would go in and say, oh, these crops right here are doing really, really well. These crops over here aren't doing too well. Which one am I going to take the seeds from? The one that's doing really, really well. That's what I'm going to keep breeding. And so we did do this kind of natural, we're going to keep having plants and grow plants that are doing well or have grown really large, it is human modified organisms. It is genetically modified organisms that way. But for us to actually get down into the fine science of it, something that's only been happening in the past, half century. What about broccoli? So the one in the center there, that's natural broccoli. But we developed broccoli into what we see up there in the top right. Down below, cauliflower. Cauliflower is never natural. Cauliflower is GMO. What's up here? Cabbage. Down here, what is that? I have no idea what that is either. So you can see how we modify things over time. Okay, so GMOs today. Countries that are in green are where GMOs are grown today. Orange is where they're imported. And then if it's grayed out, we just don't have the data or concrete, yes or no, whether GMOs are allowed. So you can see, and then the really dark shaded, those are, they're approving research on GMOs. But we grow them here in the United States, China, India, Australia, most of South America. GMOs are constantly being grown. If you ever go and see a farm field, see crops growing, it's going to be GMO crops. See, if we take the origins of broccoli, of kale, of I guess Brussels sprouts. It's all going to be from the uh, wild mustard, the original plant. But it's been modified and changed over centuries, millennia, to become the crops we see below. Okay, so a GMO, the actual definition, genetically modified organism. An organism or microorganism whose genetic material has been altered by means of genetic engineering. But we got to get outside of this mindset of that genetic engineering only happens in a lab. It's been happening for thousands of years. Yeah. Yes, you may real quick. Now, genetic engineering is the direct manipulation of an organism's genome using biotechnology. So, genetically modified organism is simply, breeding more successful crops with each other, planting more successful crops, or the seeds from successful crops, versus actually engineering and going in and changing the genetic makeup of a plant or animal. They have seedless watermelon. Like, you guys have bought seedless watermelons, right? Is that genetic engineering or GMO? Anything that you buy seedless grapes, seedless watermelon, seedless tomatoes. Would that be genetic engineering or genetic modification? How many of you guys would say it's GMO? How many of you guys would say it's genetic engineering? Okay, good. Okay. Okay, so I'm going to go on the next one. I want to get to our videos for today. So when we're genetically engineering, there's a couple terms how we refer to changing organisms. So there's transgenic, which is a gene is moved from one non-closely related species to another. So that's like, yeah, it'd be like taking genes from a pig and implanting them into a cow. There have been genetic scientists who have tried to make a combo pig and cow. Then you have cisgenic, intragenic. Gene is moved within the same species or closely related species. So this would be basically, combining types of cabbage or types of corn. Cisgenic is a lot more common than transgenic. Then we have subgenic. Gene is edited to amplify, delete, insert, silence, or repress the gene. So this is going to be one like, for example, if we need to produce a certain enzyme that is going to kill off mealworms on a piece of corn, that would be subgenic. I'll give you guys a minute to write down. Now, like I said, I know this isn't the most fun information, but I think the video will do a lot better than this unit right here. The training I had was environmental science, which I didn't do as well as I would like to have done in that class. So I'm learning this information just as you guys are as well. So, like political geography, I know all of that stuff. But when it comes to agriculture, specifically GMOs, this is a learning opportunity for all of us. Okay. So this is just going into more detail as to like kind of like a chart going over different types of genetically engineering, modifying organisms. We won't spend too much time looking at here, but you can see where we've made like hybrids, so crossing two different plant species to create a new one. or what's the trying to think. Because a donkey is it donkey? Trying to think. There's an animal. There's like some type of animal that has been is a hybrid of a horse and trying to think of the other. Yeah, mule. A mule is a combination of a donkey and a horse, right? Yeah, that is genetically engineering right there, but it's been happening for centuries, just naturally. People realized they could combine those two to make a better transport animal, a mule. So that'd be a hybrid. So these are some things that we've done with GMOs. These are some genetically engineered crop traits. So a biggest one that's probably most GMO or genetically engineered crop trait is herbicide and insect tolerance. So herbicide tolerance are Roundup Ready crops that have to be bought every year. Insect tolerance. So the plant will produce some type of toxin to kill off that insect. Improved nutrition, disease resistance. So there's disease resistant forms of potatoes, but ironically, Ireland bans GMOs. And we'll talk about that here in a second. Stress tolerance, increased storage. So basically, you can store grains longer without them going wrong or going bad. And then medicinal uses. So can anybody think of a medicinal plant that has been modified from its origin? Can't get it here in Utah. Well, you can get it in Utah. It's very regulated. Marijuana. Maybe this will waken some heads here. Medical marijuana. Prime, great example, genetically engineered. Because what's the component of marijuana that makes it illegal? THC. It's the thing that gives you the high. And so there's so much other medical benefits to marijuana outside of the THC. And so labs have developed forms of cannabis, marijuana that don't have the THC. And that's what's legal here in Utah, is you can get the non-THC version of marijuana. Huh? What?
Anyone can buy it now?
Well, you have to meet certain conditions. You have to have certain ailments, chronic ailments, versus like a state like Colorado, where you can get recreational marijuana legal, but you can also get medical marijuana. But that's another example of finding the medicinal uses out of the plant. Another example, have you guys ever had aspirin? Aspirin comes from a plant. And so obviously when you take a pill, an aspirin pill, it's not a little piece of plant. They've taken the medicinal products or properties of the plant and put it into a pill form to consume. Yeah. Yeah, anytime you're not actually using the plant itself and it's like the stuff has been extracted or made into like any type of like cream or pill form. So yeah, like a lot of medicines, more natural medicines, genetically engineered and modified. Okay, so this is just going back to the malnutrition and talking about vitamin A deficiency. Now, you're probably wondering, why am I showing vitamin A deficiency? One of the most successful genetically modified crops that came out of the Green Revolution, what we call golden rice. Rice by itself, original white rice, doesn't have a lot of vitamin A in it. any of our nutritionists, nutritional people here. Traditional white rice has no vitamin A in it, even though that's like the base diet for a lot of people, especially in sub-Saharan Africa and Southeast Asia. And so scientists came up with this golden rice, which has vitamin A injected into it. And now when they grow this golden rice, people are getting their vitamin A a lot easier, a lot better. And this came about around 2005. So the map of vitamin A deficiency, a lot less. But then again, this crop costs a lot more money. And somebody in Southeast Asia is going to buy the cheaper white rice seed than they are the golden rice seed. Just showing where most of the GMOs are grown today. Okay, I want to make sure we get to the videos. So these are genetically engineered crops that are very common in the United States. Onion. Wait. Is that onion? Does that say onion? No, cotton. Cotton, sugar beet, soybean, corn, canola. You guys ever had canola oil for cooking? Yep. That is genetically engineered. Papaya. Papaya is just a big crop for Hawaii. They had a disease that came through that wiped out most of the papaya population of Hawaii. Scientists got together and made a genetically modified papaya seed that is tolerant of the disease or fights off the disease. Okay, and then we have some GMO crops that have yet to be approved here in the United States. How about the Arctic apple? Which, out of that apple, which one would you probably eat? Who here thinks they would eat the top one? Who here would prefer the bottom? So the modified part of the apple is the top one there. It's made, once again, to appease our sense of what a good fruit looks like. Same goes for potato, innate potato. The one on the right, I don't know. I don't want to make no whipped potatoes with those. But I think the one to the left looks more appeasing, more appealing. And if I'm at the store, I'm probably going to buy the one on the left than the one on the right, even though they're both functionally the same. This is one that might blow your guys' head. 90% of cheese. So this is going to be 100% in all the like store, Kroger, Walmart brand cheeses out there. Rennet is a complex of enzymes produced in stomachs of ruminant mammals, which is used in the production of most cheeses. Plymosin is its key component is a protease enzyme that curdles the casein in milk, helping young mammals digest their mother's milk. So this enzyme they take from animal and inject it into your cheese. So you basically have a little bit of mammal gut in your cheese. Okay. All right. So for the recorded Zoom, I'm going to go ahead and end here. They'll watch the video on their own.